All right, now this is a part 2 video about how to graph linear equations. You'll notice up top we've got an equation that's going to be x to the first power, right? If we don't write an exponent, it's always first power, and y to the first power. Therefore, we know this is a linear equation. It's actually in what's called standard form, where you've got the x coordinate and the y coordinate, right? The x term and the y term either added together or subtracted, right? Addition with a negative, where those are added on the left, and then you've got a constant c over here on the right. Now, that's a little bit tricky to graph unless we know some fancy ways to do so. And right now we want to graph using a table. So the easiest thing to do is go ahead and rewrite our equation. Let's solve our equation for y. Right? We've practiced doing this before. Let's solve for y. So what I want to do is move my 3x, right? I want to move that term to the right side. Now notice, again, we've got 3x minus 3x, so that's gone. But I've still got a minus y here, so don't forget that's going to be negative y equal to. Remember that 2 and 3x, right, are not like terms because of that x. So therefore, we're going to have to write those out. Now, I'm actually going to write it in kind of an odd order. I'm not going to say 2 minus 3x. I'm going to say negative 3x plus 2, right? It's a positive 2. Again, we're really adding those together. It's just that the 3x has a negative involved, right? So let's just kind of keep that in mind. Now I've got to finish this up by getting rid of that negative on the left side. I'm going to divide the entire right side by negative 1. Negative y over negative 1 is y. Negative 3x over negative 1 becomes a positive 3x. And 2 divided by negative 1, that addition just became subtraction because 2 divided by negative 1 would be negative 2. So again, we've got our nice equation here solved for y, sometimes what we call function form. Y equals everything there. Now we can go ahead and find some points and let's get this job done here. So I'm going to just pick a few numbers. So how about we just go with 0, 1, and 2. If you want to, you can plug in a negative number like negative 1. Wouldn't be a bad idea. So this became 3 times 0 minus 2, which is negative 2. And I can plot the point 0, negative 2. Let's make sure we're counting by ones on here, right? Make sure we label those axes, right? Counting by ones. 3 times 1 is 3, minus 2 would have been 1. So I can plot the point 1, 1. And again, plugging in 2, I'm going to multiply that by 3, right? 3x minus 2. So 6 minus 2 is 4. And I'm going to plot the point 2, 4. Notice how our points, we went up 3 and right 1, up 3 and right 1. We get that nice pattern going on there. We'll talk more about that in the future. And also we could go down 3 and left 1. So even though I didn't find this coordinate, my guess is at 1, right? Negative 1, I should say, at negative 1, negative 5, down in quadrant 3, we're going to have a coordinate there as well. We plotted our points. Let's connect our dots. And don't forget the arrows. Why don't we try that one more time? I'll go a little bit quicker this time. So notice we've got our equation up top. So step 1, solve for y. Feel free to pause the video if you'd like to and try this one out on your own. And then check your answer as we go. First thing I'm going to do is add 2x to both sides. Make sure we write that out. So we get a 3y equal to 2x plus 9. And then I'm going to divide everything by 3. Right? So that became y equals 2/3 x plus 9 divided by 3 would be 3. Make sure you divide both terms. Well, that means let's plug some numbers in. Again, 0 is always a great place to start. Because we've got this divided by 3 going on, that 2/3 going on there, I'm going to go ahead and use multiples of 3. I just think that would be a helpful thing to do. Then I don't have to deal so much with the fractions. So I'm going to use a 3 and a negative 3. So 2/3 times 0, well, the nice part is that's always 0. Plus 3 is 3. So again, 0, 3. Then we're going to plug in 3. 2/3 times 3. Well, those 3's cancel. We get 2. Plus 3 would be 5. So I'm going to go out to 3, 5. Right there. So it looks like our pattern is, again, going up 2 and right 3 and up 2 and right 3. So I'm guessing we'll get a point there. But let's check that out. Let's make sure our third point also works. 2/3 times -3 plus 3. Well, 2/3 times -3 is -2. Plus 3 would be 1. And at -3, 1, notice down 2, left 3, down 2, left 3. All of these points, which we could easily plug into our equation, fall on a nice straight line, right? As far as we go there. Hopefully you hit your points a little better than I did. But again, assuming we're counting by ones, so let's go ahead and just label our axes right there. 1 and 1, or you can go all the way out here and say, well, hey, that was 10. Right? Counting by ones, there's our nice line. Okay. Now, a couple of other lines that we want to glance at very quickly. What if we wanted to graph these two equations? Now, you might think that's an ordered pair, right? X being 2, y being -4. But notice it's an equation, not a coordinate. So if I wanted to actually create a table, right? If I wanted to do that on my screen, for the blue line, right, I have to say that x has to be 2. Now, since there's no y in the equation, y could be anything. Y could be -1, or if x was 2, y could be +1, or y could even be, 5. Well, that means that if we go to 2, 1, right, or -1, or 5 there, right, notice all of our points fall on a vertical line. They make a nice vertical line straight through those coordinates. If ever you have an equation that's just x equals, right, there's no y in the equation, that's a vertical line. Because all of the x coordinates are the same, they're all on that line, x equals 2, right? Where the y could be anything we want it to be. It's not even listed. Well, the same thing goes when we talk about y equals -4. What if we create that list of coordinates? Well, now if x is 2, y has to be -4. If x is 0, y has to be -4, right? According to the equation, that's what it says, y equals -4. Or basically, every coordinate, right, has a y value down at -4. Oops, it looks like that one's plotted a little low. I'm going to move that up just a little bit. So we're right there, right? Maybe means I got to move these lines out of the way. But again, that horizontal line, let's make sure we end up in the right spot here. Right there, where y equals -4 the whole time. Okay. So hopefully that helps you with horizontal and vertical lines. Again, vertical lines are always x equals because all the x coordinates are the same. Y equals would be a horizontal line because again, all the y coordinates are the same on that horizontal line. Okay. Finally, let's talk a little bit about functions. Again, if we want to actually use linear equations, what we want to be able to do is kind of apply this to the real world. So you'll notice a fashion designer orders fabric that costs $30 per yard. So notice as the number of yards F of fabric increases, we're going to increase by 30 each time. But we're also starting off with a flat cost. We'd also like the fabric to be dyed at a cost of an additional $100, right? $100 there. So the 100 is just a one-time fee as far as that goes. Right? So if we order 0 yards of fabric, well, technically we still got to pay for the dye, so that's going to start us off at 100. 5 would be 150 plus 100 is 250, right? 10 would be 30 times 10, right? We're plugging our number in for F right there. So 10 times 30 would be 300, makes 400 when we add that 100 on. And again, 600 plus 100 would be 700. So notice we get pretty big numbers there, right? Now, why does it make sense that we would restrict our domain? Well, we can't really buy negative amounts of fabric, can we? So you can't really order negative amounts of fabric. So it makes sense that our domain should start off at 0, right? And notice we're doing 100 up to 700. I'm going to go ahead and make my tick marks into 100. 2, 3, 4, make this 500, right? Why count by ones when you don't have to? And also I've got 0, 5, 10, and 20. Why not count by fives? 5 makes 10. This would be 20 out here. We can go up to 30 or beyond there, right? Well, very simply, I could plot my points and I could draw that line, right? But now notice the graph here, we want to do it for part C. And notice in part C, the designer decided, wait a minute, I want 5 to 20 yards. My domain is only going to be from 5 to 20. So I only want to be sort of between, this area here, right? So I want to plot 5, 250, and I want to plot 20, 700, right? 506 makes 700, and I don't want to go beyond there. I'm not going to draw any arrows because really I just want to be in between those. And I could even plot 10, 400 if we want to. Notice that should fall nicely on a nice straight line. But again, our range is going to be limited because our domain was limited. We're only between 5 and 20 for the domain. So notice on our graph, we're between 250, right, and 700 on our y-axis, right? Our line stopped at 700, and our line started at 250. So therefore, our range of our graph is also limited. 250, less than or equal to C, up to 700, right? C falls somewhere in between those two numbers. Again, I hope that helps you with linear equations. I know we went a little long there, but if you have any questions, make sure you talk to your teacher, and have a great day.